Hey guys, today I'm going to teach you all about experimental and theoretical probability. By the end of this lesson, you'll be able to compare and contrast experimental and theoretical probability and make predictions using the relative frequency of an event. So go ahead and get out your binder, turn to the math section, and let's try to take some notes. When we talk about simple probability, the odds of getting heads or tails is equally likely. Same for the chances of spinning a spinner and getting a given color, or rolling a number cube and getting a given number. What we should get isn't always what we do get though. If we flip a coin 10 times, theoretically, we should get heads 50% of the time, or 5 out of those 10 times. But in reality, that doesn't always happen. That's the difference between experimental and theoretical probability. Theoretical probability is what should happen. If I flip a coin 10 times, I should get heads 5 out of those 10 times. Experimental probability is what actually does happen. If I flip the coin 10 times, I could get 7 heads, I could get 3 heads. So the easy way to just remember that is theoretically, what should happen isn't always what does happen in an experiment. A more formal definition of experimental probability is that it can be defined as the ratio of the number of times an event occurs to the total number of trials. Theoretical probability can be defined as the probability of an event happening based on the possible outcomes. Let's break those apart and look at the difference. We'll use the example of flipping a coin, and let's say we do it 10 times. So out of 10 possible times, I should get heads 50% of the time, 5 out of 10. Just now, I flipped the coin 10 times. Out of those 10 times, I got heads 3 out of the 10. That is my experimental probability. It's going to depend on each time you do the experiment or do the trial. Theoretical probability is never going to change. That is a constant. It's what should happen. And that's the difference between those two. So for this section, we're going to break apart the difference between theoretical and experimental probability again. This time we're going to use a spinner. So using the spinner below, we're going to answer some questions. In this box, it's all about theoretical probability, so you'll be able to do that. In the table, you'll have to get a spinner and do some experimental probability questions. So you should be able to answer A, B, and C by yourself. Just looking at this spinner, go ahead and pause the video to answer those questions and press play whenever you're ready to check. All right, so looking at the first question, there's one section with stripes out of the 8 possible sections, so 1 out of 8. So in theory, if you spun the spinner 8 times, you would get the stripes 1 out of those 8 times. For B, it says, what's the theoretical probability of spinning a section with stars? Since there's 2 pieces with stars, 2 out of 8 times reduces to 1/4. So if I spun the spinner 4 times, 1 of those times I should get stars. If I spun it 8 times, I should get it twice. And part C is asking about the theoretical probability of not spinning a solid or a striped section. So I want to circle the striped and I want to circle the solids. Since there's 5 of those, I know that the odds of getting a striped or solid is 5 out of 8. The complement of that is not getting that. That's why I put 3 out of 8. So that's theoretical probability. That's not going to change. That's what should happen if you spin the spinner. But what we're actually going to do is spin the spinner 10 times and complete this table below. We'll tally up how many times we got stripes, white dots, or stars, and then we'll calculate the experimental probability by dividing the number of times we got it divided by the total number of spins, which will be 10. If you have a spinner like this and you can perform this experiment, go ahead and do that now. If not, you can just follow along with me in the video. I'm going to perform the experiment and you can see my results. So pause now if you can, and then press play when you're ready to check. All right, so here were my results from the experiment. If you notice, they're not going to match the theoretical. The big idea is that the more times that I spin the spinner, the closer I should get to the theoretical probability. That's the big takeaway for today. So that leads us into our discussion about relative frequency. Relative frequency is the total number of successful attempts divided by the total number of trials. It can be used to make predictions. When we're talking about relative frequency, we're talking about experimental probability. So in this table, the relative frequency of spinning white would be 50%. The relative frequency of spinning and getting dots would be 10%. And like I said before, what you'll start to notice is that as the number of trials increases, the relative frequency of an event will approach the theoretical probability. So in my very first example, I talked about how I flipped a coin 10 times and got heads 3 times. Keep flipping that coin, let's say 100 times, I should get closer and closer to my theoretical probability of 50%. So let's see that at play with the spinner below. The spinner at the right is spun 50 times, and the results are already in the table below. We're going to complete the experiment, starting with finding the relative frequency. I'll do the first one for you. Since it was spun 50 times, and on my relative frequency is the total number of successful attempts, so in this case for 1, getting it 12 times, out of the total number of trials, in this case 50, I can write that number as a fraction, 12 out of 50. Since both of those numbers are even, I know that 2 goes into both of them, so when I simplify, I just divided both numbers by 2. I got 6 out of 25. You can also write this number as a decimal or a percent. And I do that by dividing. 6 divided by 25 gives me 0.24. Move the decimal over 2 times to get 24%. So go ahead and fill out the rest of this part of the table where you're finding the relative frequency, and then press play whenever you're ready to check. All right, so here's the relative frequency from this experiment. Remember, this is after the spinner was spun 50 times. So let's try to spin it 100 times now. Again, if you have the spinner, go ahead and do this trial. If you don't, just follow along with me in the video. All right, so after I spun the spinner 100 times, this is what I got. I got 121 times. I got the number 2 19 times, 3 18 times, 4 23 times, and 5 19 times. Now let's calculate the relative frequency of that. All right, so I got my relative frequency by dividing the number of times that I got a certain number divided by the 100 times in total that I did this, and I got my relative frequency. So all of this that I've been doing so far has been experimental probability. But let's take a step back and think about theoretical probability. In theory, the probability of getting a given number on this spinner is 1 out of 5. 1 out of 5 as a percent is 20%. So what did you notice as you spun the spinner 100 times? Did you discover any patterns? Pause the video now to think about that and press play when you're ready to check. Theoretically, the probability of landing on each number is 20%. So after 100 spins, we got closer and closer to that theoretical probability. The experimental probability will get closer to your theoretical probability the more you do the trials. So just to break that down even further, the theoretical probability of spinning each of those numbers was 20%. The more times you would spin that spinner, the closer you should get to a relative frequency of 20%. If you spun it 1,000 times, you should get closer to 20%. If you spun it 100,000 times, it should be really, really close to 20% for each number. So if I had to summarize today's lesson for you, the experimental probability is what actually does happen in an experiment. But theoretical probability is what should happen. That's never going to change. And as you do more experiments, you'll get closer to your theoretical probability. That's when we talk about relative frequency. We use probability to make predictions. All right, guys, that's it. If you made it to the end of this video, what I want you to do is go get a coin, flip it 10 times, and then put in the comments how many times you got heads. Today, we learned all about experimental and theoretical probability. So now you should be able to compare and contrast those two types of probability and make predictions using relative frequency of an event. Now you should go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye.